Hey, what's up everyone? Welcome to the stream. Okay, so let me get right into it. So last stream, I was struggling to implement the StepOver functionality for the DAP debugger. And after the stream, I thought a lot about what I was doing, and I had said it a few times in the stream. The fact that I was struggling with this was a sign that I was doing this the wrong way. I was hitting this at the wrong level, the wrong abstraction. So I thought about it and realized that there was definitely a simpler way for me to implement this. So if I could just let me get to where I was. DapDebugger. Oh yeah, here we go. So this is the StepOver feature. So I wrote some notes here, but ultimately I understood a few of the bugs that I was having. It basically comes down to this is what I need to support. So the idea is you'll be, let's say, at this first instruction here, and you'll hit F10 to step over, also known as next. And what it needs to be able to do is it needs to be able to execute all of these instructions and then stop here on the next one. The thing is, I chose this specific example because in this one, there are actually two jumps. So this actually corresponds to this line of C++ code. We have here a call to set string, but before we have that, we have another call here to I to A. So this is calling I to A with a couple of things, and the returned value, which is going to be an ASCII string, will be passed to set string here. So you can see that the I to A is the first call there, followed later by the set string call over here. So I was thinking about how all of that works and what I was trying to do, and I came up with a good solution which is at the right level of abstraction and will support everything. So I wrote here my notes. When we enter the StepOver state, what we need to do is we need to save the current source location. So that would correspond to the source location of the instruction we're at right now. So that basically is going to be the source location that matches for all of these instructions, and then suddenly becomes different when we're here. Also keep in mind that the source location will change when we make a jump. So this here will jump to a new source location, and the one that I had here will no longer be the same. So keeping that in mind, we save the current source location and we save the current call stack depth, because the whole thing is about call stack depth. We want to step over, so we need to basically make sure that we're back at the same call stack depth. So execute instructions until source location changes and that the current stack depth is less than or equal to the saved stack depth. So we will save let's say our stack depth is 2 when we're here. When we make this call here, it's going to become 3 and potentially more if the call we make makes more calls. Eventually it's going to return and be back at 2 when we come to this instruction. So when this guy returns, it'll be 2. What we're looking for is that the source location and the call stack depth both change. So the source location changes and the call stack depth is either equal to or less than the saved one. And I'll get to the less than part here. So as I said, when we make a call, the current stack depth will increase. So we don't want to break during that time. When we return from calls and current stack depth is equal to save stack depth, we may still be in the same source location. So we're not quite done yet, which is why we also look for a change in source location. This also takes care of multiple calls in the same source location. So like I was saying, when we make this first jump, we come back. We're still in the same source location, even though our stack depth has returned. We keep going. Now we make another jump. Our stack depth will change. Then we come back and then we are still at the same original source location. Stack depth is equal. Then we come here. Source location has changed. Stack depth is greater than or equal, and we're done. So the reason for the less than compare is because if we're on the last source location of a function, So for example, the closing brace, which is the return, like the closing return brace, then the next source location will actually be at a lower stack depth. Okay. So for example, if we imagine, for whatever reason, let's say this instruction isn't there, we're here. What would happen is, actually no, this isn't a good example. We'd have to have an example where we have a return, let's say a return from subroutine. Let's say the last instruction we execute is an RTS. So we're returning from a subroutine. All of a sudden, we are no longer in the same source location, but we're no longer at the same stack depth either. We are at a lower stack depth. So we pop off a frame, and so that's the reason for the less than or equals to. So in the end, we don't need the conditional breakpoint thing, so I'll be getting rid of that. And for step out, yes, for the step out case, it's the same thing except that the condition is source location changes and cur stack depth is strictly less than the save stack depth. So it's really exactly the same as StepOver. The only thing that changes is rather than less than or equal to, we're going to be looking for less than. So, so that's basically the plan. Now, in order to do this, I have to be able to save the current source location and the current call stack depth while I'm in this state. And that's the only thing, is that I don't have right now with my current state machine a way to save nor to know when I've just entered a state. So I thought about that. So the first thing I could try to do is maybe hack it up just to proof of concept this, make sure it works. But ultimately what I want to do is make a proper state machine very much in the same way that I wrote one for the RST parser. Right here, this is a state machine making use of, here you go, making use of stood variant to hold the different states, and similarly making use of these structs, or basically state classes, so that I can hold on to data that gets constructed and destructed as I enter and exit states. So that this way I can know, for instance, when I've just entered a state, I can save data as part of my state. So all the good stuff you get from an object-oriented state machine. I'm going to pretty much need that here. In fact, I'm even wondering if I should just proceed with that right away. It shouldn't be very difficult to do this. The only difference I was thinking about it is right now this run state is an enum that I do here, that I set here. I'm going to want to change that a little bit, and I think it's still a good idea for me to do that, is have like a target state that I'd like to go to, and then make checks for like this target state from within my state machine, rather than slamming the state like I am right now. I think that would make a lot more sense as well. Yeah, still thinking, should I try to hack this, or I don't know. See, like all this code, almost all of it's going to go. In fact, you know what? Let's immediately take care of this code. I'm just going to grab, I think it's up to here. Let's go like this. Just cut that. I'm going to paste it somewhere just so I don't lose it, in case there's something useful in there. Yeah. Okay, this is getting annoying. I'm having this low disk space on my backup drive, which is why I keep getting notified. Is there a way I can let me put myself into focus assist? I think that's gonna work. Oh, hey, Jono. How's it going? I am personally doing all right. Things are continuing to be kind of depressing and scary, I mean, related to COVID, but, you know, do the best we can, right? Okay, so I think I will do the thing, or because the only hesitation I have is the entering of the StepOver is detecting when I've just entered into it, because I just can't know right now. All right, let's try this. Or actually, this is going to go away, but I just need to know for now. So, all right, let's say if the last run state is not equal to the current state, so we just entered the state. So this is where I'm going to get a little bit hacky for now. I just need to remember so what should I call this? I called it the saved stack depth, I guess. I don't really want to call it saved, but so let's call it initial source location, and I don't know if it's a size T, but initial stack depth. All right, so let's say we just got into the state. So we'll say initial source location equals, and we will get the current source location exactly like as we do here. We will also get our stack depth. Oh yeah, so this might actually not be valid. So what happens if we have an invalid one? Not sure yet. what should we do if the current source location is not valid? I mean, the truth is, I think we can almost assume it will be, because if we're stopped in the debugger on a line, it's because we have a source location. So maybe we can assume it. Maybe we can assume it, since we should only be able to step over a valid source location to begin with. Hey, why isn't my extension? Why isn't client format working? Let's see here. I very much need this. There we go. Tools, options. Format and save is set. Oh, okay. That was weird. Okay, back to working. All right, so initial stack depth. So that we will get from the call stack. Get my frames dot size. All right, so we save those. Then what did I write here? Save the current source location and the current call stack depth, yes. So we execute instructions until source location changes and current stack depth is less than or equal to the saved. Okay. So first of all, if current source location, if this is not valid, I say we just break. I mean, I don't really know what to do there. Shouldn't really happen, but I suppose it might. No, it could happen, actually. What am I saying? It could happen. Yeah, because we could be stepping inside and like iterating over instructions that are not mapped to a source location. And that's fine. We just want to keep going. As soon as we get a valid source location, we want to start looking at the situation. So let's say we have a valid source location. So now what we want to say is if the current source location is not equal to the initial source location, and the current stack depth is less than or equal to the saved, to the initial stack depth, then we are done. So then what do we do here? We say we break into the debugger, we say we've stepped, we send a stepped event, and then and then what, do we stay in the same, let's see, control minus, okay. Wait, why am I modifying step into? I was supposed to be modifying StepOver. Oh, whoops. All right, well, that's all right. Let's just copy what we have here. Yeah, that was brilliant. Okay, that's better. Yeah, so for the step into case, I guess I would remain in the step into state, which is probably not what we need. What should we be going into? Once we've achieved this, same thing for here. Once we have stepped into something and we do a break into debugger, that sets us into the paused state. And we really should go into another state, I think. But anyway, I think it will work even if I don't change states. Okay, so let's just see what happens here. See, if this works, this is obviously a lot simpler than what I had going on before. Okay. So let's hit F5 here. And just want to make sure I'm building release. So I think this is the release one. Okay, so F10 there did not quite do what I expected. So there's something to look at there. And here, F10 is not doing what I expect. It's not quite there. All right. Let me just take a look here. Oh, right. One of the things is I will need to break out of the state so that I can reinitialize these values, of course. Okay, so let me try something. Let me put myself into. I guess I need another state. Let's call it paused. It's really just any other state, I suppose. Yeah, because then what happens is last run state will be equal to paused. Yeah, with a proper state machine, this is going to be much easier than this kind of garbage. Okay, so let's try that. Oh, hey, Pyro, and Bama. Thanks, man. Stay safe to you as well. We all need to stay safe. You guys are okay in Singapore? That's good to hear. We're okay over here in Canada. But, you know, these situations can change fairly quickly. Not sure what's going on here. F10 here brings me, unfortunately, to this return right there, so that's incorrect. Then when I do init here, looks like I got a crash. Probably my assertion there is invalid. Oh, you watch my Prime Minister? Oh yes, that's right, you're French. I think you told me that before. Yeah. Okay. Yeah, 2020 is crazy. It has been pretty nuts so far. All right, so let's try this. We're gonna put back the wait for debugger attach thing. Yeah, let's code some more here. Let's actually get this working. I have to say, it's not easy to develop everything on one monitor here. Normally when I'm not streaming, of course, I use my 2 monitors. But obviously for the purpose of the stream, I try and do everything on this one screen, which can be rather challenging when you're doing this kind of, you know, debugging back and forth like this. Debugging a debugger. All right, so let me put myself here. So I'm going to hit F10. So that's going to set my run state into StepOver. Currently it is running. So these two are not the same. So that assertion seems all right. I'm going to get the initial source location. So that's source main.cpp line 39, so that looks right. Now what that corresponds to would be shown here. Let me go to here. No, not that one. There we go. Does this look right? It does not look right. So this is the one I was looking for. Okay. So there are 2 instructions for this one before we change to line 40. So that we expect to see us running through here for at least 2 instructions with no calls. All right, so we get our stack depth. It is 2. We know that this is the initial source location. So we execute that first instruction, which is the push. Then we check the current source location. It should be the same. It is still line 39. Perfect. And our stack depth should be the same. So we're not done yet. So we're still in the same state. We continue as is. Oh, actually. All right, so that's my first mistake right there. I need to bring this inside my my while loop here. Yeah. I also notice I have some returns here, so that's going to totally mess me up. So in fact, what we'll do is we'll do this. So what is it called again? Scoped exit. So here, this just guarantees that when we exit this scope, we always set the last run state, but I also have to set it not just when we exit the scope. I wonder if I could put it in the switch. But anyway, so what we'll do is we do this. Yeah, and this is just redundancy, just in case we do a return. Honestly, I don't think I need this return because we just break anyway. So let me, you know what, let's do that instead. So technically I shouldn't need this. Oh, I need to stop the debugger here, or I will lock the file. Okay, F10, we come in here, initial, execute, and then we update the last run state. So now we execute the next line, and now we have broken into the debugger, and we should be here. Perfect. Now we do F10 again. So we enter StepOver. This should be the first time. Perfect. Initial location. Now we should be at line 40, and we are. Same stack depth. So for line 40, come back here on this tiny screen, and tiny window, I should say. So line 40 starts here, and actually it starts with a jump, right? Because we're doing a call. So this is going to be an interesting case. We're going to make a call, and we will eventually come back to this line at the same source location. So let's see. We do this. So we should see a stack, both of these should change. Source location is now line 35, which I believe makes sense. Let's see. Yeah, because we're now on the foo line, line 40, calling foo. So we're now at line 35. And the stack depth is 3, so we went deeper, right? This condition should not be true because although the source location has changed, the stack depth is not less than or equal to the initial. So sure enough, we do not break yet. And basically, we should be in there for a little bit as we execute the print. See, now the stack depth is 4 because we've entered the print. So yeah, this is going to go on. So let's just see if it's working. I'm just going to hit F5 here. Oh, that looked good. So if I hit F10 here, oh yeah, I got to remove this breakpoint as well. Perfect. That looks good so far. So let's open this up a little bit. F10 here, F10. Now this here is going to wait for us to do that. There we go. See, this is what we expect. Wait a frame. Move. Let's see. Is this loop stuff working? Collide F10. So it did not collide, which is why it's returning false and going back up here. F10, F10. we're not at the top. So that was another condition. F10, F10. We should go in here for the few objects we have. F10. Right, we were here, and then F10 brought us to the top, onto the next. So yeah, this looks like it's working. So let me just check. There was a very specific breakpoint that was causing us trouble last time. Let me maximize this. What was my example again? I mean, I think it is working. Yeah, it's, oh, so I think we actually saw it work. Yeah, score text, set string, I to A. So that's basically this over here. Right, if I hit F5, we should get there. F10, you see F10 totally works now. F11 should bring us into the I to A. Return. And then F11 again should bring us into the set string. And then we're done. Beautiful. So there you go. So much simpler than what I was attempting to do last time. So now we just need to actually clean up this mess of hacky variables and bools and stuff and do it with the proper state machine. I also now understand why we got that crash, because since I wasn't updating last run state correctly, we were totally always executing the code inside this if, and as such we were definitely hitting a location that did not have a source location, an instruction I mean. Okay. All right, so let's start doing this thing that I want to do. So let's include variant here. So we'll make some structs for all the different states. We've got running, pausing, we've got step into, we've got StepOver for now, and we'll stop there. Stood variants of all of these. Actually, I am going to need one, which we'll call paused. Or maybe, yeah, I suppose we'll call it paused. It basically represents the state of being paused or broken into the debugger. And actually, we will actually want this on the outside. Yeah, that's the only thing that sucks a bit. Well, it's all right. See, this here is going to become the target state, you know, or the desired state. It's going to be or the request. You know, we're going to request a state, and then we're going to from the actual current state, we're going to look at the request and decide, you know, what transition to make or whatever. Which is actually a good idea, because it means we don't slam ourselves into another state from the outside. We make a request, and then the main loop decides what to do. Okay. So yeah, I'm not going to need that anymore, but we'll get rid of that afterwards. So okay, so basically in here, I'm going to make use of my utility that I wrote. Was it in StudUtil? I think so. Oh yeah, and I should probably initialize my state. So this one here, visit overloads. That comes from my StudUtil. It does indeed. All right. Pass it a state, and then we start passing it basically captures for each of the states. So let's do this. We've got all of these. Okay. All right. And put some comments in there to get these to line up. Okay, that looks good. In fact, I think I can just do this. All right, there we go. So running is going to do this. Pausing. Step into looks like this. Now step over, which is what we just wrote. This will change, of course. Now here return does not mean return out of everything. It means return from this scope, from this lambda expression here. Okay, let me just see if this builds. Okay, that's fine. We're getting some unreferenced formal parameters for my ST names here. So actually, you know what I'm going to do is I'm going to actually remove them and put them in if we need them, because I may not actually use these. For the most part, they are only useful as a way of knowing which state you're in, but if I use them to store data, then I'll actually want to to have the variable there. Okay, so that builds. In fact, this should not only build, it should run exactly as it was, except for the fact that I am not handling, let's see here. Yeah, so the run state that was being set here, I now need to handle this. Yeah, I'm going to start off by doing it like this. The multi-cursor thing in Visual Studio is not as good as in VS Code, I noticed. So let's say we want to go into, yeah. Just thinking how I want to handle this. For now, let's just try this. If the last run state is not equal to the current run state, that means we have been asked to change. So let's just do this. So yeah, I am definitely just slamming the state here, but it's done in one place and we can change it afterwards. Because what I might do is do these checks from within the states and say, like, from this state, what transitions do I allow? I haven't handled StepOut just yet. I guess we could add it right away. Just get rid of that. Okay. Yes, and we need to add it to our list of possible states. So let's see if I broke the world here. Hopefully not. I need to attach, it's true. Attach the debugger. All right, F10 looks like it's working. Show the game select screen. F11 looks like it's doing its thing. All right, so it looks like I did not break everything, so that's great. Let's break out of here. All right, so let's do the thing with the state. Okay, so what I was going to do is get rid of these statics here. And the way we're going to do that is we're going to add these as fields of the StepOver state. So this is our state here. I can pretty much copy these here. So we want initial source location. We want initial stack depth. And for lack of a better way to do this, we're going to add a bool to say whether or not this is the first time we enter this state. So let's call it entry, and we'll say true. So upon entry, this will be true, and then we can set it to false. So when you default construct StepOver, it will set entry to true, and then default initialize these two members here. So what that means is what we can do here is we get rid of this. Okay, put a st to represent our state. And we'll say if st.entry, so if we just entered the state, immediately set it to false. And then these guys here, we access them from the state. So we store in the state the initial source location and the initial stack depth. So actually what's interesting about this is we could also say, you know, let's say like there's an assert here, but maybe we don't necessarily have a valid source location to begin with. We could keep stepping until we do, and once we do, we could set this to false. It would be a bit of a misnomer. It's not really entry, but more like initialized or something like that. And so that would be one way to get around this. But the point is we're keeping it in the state, because this state is remembered frame after frame. So the first time it comes in, this will be true. We set it to false, we initialize. The next time we come in here, this will be false, so we won't enter into this block anymore. And we will have the last location ostensibly in here. What's the problem here? ST is undefined. Okay, so let me just see what's going on here. I am missing something. Oh, okay, wait. Oh, yeah. Open brace. Here we go. Perfect. Okay, so that's built properly. Let's make sure it works. Every small incremental change should be validated. Okay, looks like it's working. Okay, so that means that this could actually be moved up for now. Okay, and then here, I'm going to rename run state to something else. I'll call it target state or something. Yeah, I'm not a huge fan of this idea of having these duplications and names, but the alternative to this, oh, this isn't really much of an alternative. I think I will have to go with this. Yeah, I think it's all right. So now we can see here that in our DAP protocol, when something is requested, we set a target state for it, and then right now we just handle them right here. For now, when target state changes, just slam into that state. And there is something here that instead of this, yeah, that's the other thing I don't like about this, is that we have this kind of mirrored version of what state we're in. And if I decide to change state from within here, I would also have to update the target state, which is not great. What do I want to do with this? So the other alternative would be to use a variant as well, but I don't think I can do it atomically. That's the one thing. So yeah, not great. I'd have to put a mutex around it, and I don't really want to do that. Because the problem is, okay, let me just clean this up here. So I don't want to do this here. What I want to be able to do is say state is equal to, and then just say paused. Like that. But the thing is that now I do this, the target state is not itself paused. Which is probably okay. No, it's not okay. This needs to reflect the current state. Yeah. The alternative to this would be to do another set of visits over all the states and do this kind of transition check. Maybe that's what I should do. Okay, you know what? I'll deal with it later. What I'm going to do is I'm going to put a little to-do here. Find a better way to handle state transitions. Yeah, not happy with this. But it's okay. I'll think about how to do that more elegantly later. At least it's working. So now we should be able to do step out in exactly the same way. So yeah, in fact, it's exactly the same. So for now, I'm just going to copy paste, and we're going to see what that looks like. If I'm correct, then all we have to do is change one character. We copy paste and we change this to be less than. So that should be step out, and we just need to say that we want to go to step out. So let's go to up here. So step out is this request right there. Okay. Perfect. Let's give this a whirl. Oh, yeah. All right, so here we are. Let's start by stepping into foo, into printf. It's not really multi-line, so it's not going to help much. Okay, let's just try something else. In here, can I get something with slightly more lines? Ah, here we go. And F10 just, I think we just crashed. No, we didn't crash. That was weird. Oh, something weird's happening with the F10 here. Okay, so I somehow broke F10. Let me go see. Probably something stupid. I am thinking that maybe the problem is the fact that I moved this. Because I was just thinking about when we do break into debugger, we never recycle up here. Yeah. That's it. If we do break into debugger, what happens is that we end this loop and we don't save what the last target state. That's the problem with this kind of saving of last state. It's always a pain. Okay, now it looks like it's working as before. So it was that. So let's see. I need a good example. Try and find something I like. Okay, this is a pretty good example right here in update audio. So let's say I'm here. I'll put a breakpoint actually. If I do Shift F11, this should step out of update audio, and it should be like here on read buttons in the wait frame function. So I'll do Shift F11, and there we go. And now Shift F11 again should bring us up and to line 116, I suppose. So Shift F11, and there we go. If I do it again, yeah, we should be playing because now we're in the infinite loop of the game. So it's trying to step out of an infinite loop. And if I ask to pause, yeah, this is what I was worried about, is it's in this state right now where it's looking for, yeah, that's something I need to handle. Let me see here. So last state is pausing. We were in pausing. Our current state. Hey Pyro. Yeah, thanks man. Index 4. That's not helpful. 0, 1, 2, 0, 1, 2, 3, 4. Yeah, that's what I thought. Is that we currently are in the step out. So what happened there? We asked for pausing, but we didn't go into the pausing state. Yeah, see, we're still in the step out state. Curious. Because when I hit the pause button, I would have expected it to enter pausing here. Why didn't it do that? Okay, so Shift F11, and now if I do pause, we hit this breakpoint here. So this is what I wanted to see. If we set state to pausing, shouldn't we be in that state? We are in that state. Okay, so we're not yet on a valid source location, but eventually we should be on one. And here we are. So we break into the debugger and we say we've paused. So this time it worked. But clearly it doesn't always work. Okay, strange. Ah, see, this time it didn't work. Yep, debugging a debugger. That's what I spent all my time doing. I gotta see it again. Let me take off a couple of these breakpoints here. Shift F11. Pause. See? It's weird. I think I know what's going on. So what's going on here is it's just a race condition. I hit pause, it goes and sets it to pausing. But when it does that, it gets to the point where the last target state gets set to pausing, and it never gets a chance to run this loop here. So let's say it was anywhere inside one of these functions, and I hit pause. So yeah, it's just a classic problem of race conditions. Because I'm not doing this in any way correctly, this is a very racy, it's not very good thread safe code. And it's somewhat on purpose because I wanted to just kind of get it working with the basic assumption of like things are paused and all that. Getting it to work by pressing any command at any time was a challenge that I wanted to tackle a bit later. And here is an example of where it can go wrong. It's especially visible now because I have this window of time between, or at least I have this distinction now between the target state and the actual state, which is why this has gone awry. Okay, let me try something. Target state. So let me see. If the target state is equal to the current state, return false. Otherwise, switch the target state this way. Okay, so the idea here is that from a state, we can check for a transition. And what we do is we tell it what is our current state. So not amazing, but it does mean that we can do this. and get rid of the last state, because basically we're using the knowledge of our current state. So what I'm doing is that each state now does a check for transitions before it does anything. If there is a transition, this will actually make the transition and return true. So we just get out of here. Stop this here. So this means we don't need the last target state, which means we get rid of that racy condition there. Okay, so let's get here. Okay, so pause worked there. So let's shift F11 out again. F6 is pause. Pause. There you go. Seems to be working. At least I haven't hit the problem just yet. Oh, sorry, here. All right. I mean, I don't love it, but definitely better than what we had before. And it's a step in the right direction anyway, because this way each state still takes care of its own transitions. There's a transition to make, makes it and returns true. Okay, so now let's take care of this very copy-pasted code and try to put it together somehow. Now, because it's not a switch case, I can't really put them literally together, but what we could do is we could have one state that represents both StepOver and StepOut with a bool that says which one it is. You know what I mean? Because really they are pretty much the same. So we can call it StepOver or out. How about that? One thing about that though is we no longer have a direct mapping between the target state and that one, so we're gonna have to put a little bit of smarts in there. So let's see how that looks. Unless there is another way. Maybe what I could do instead is make that could be kind of clever. I don't know if I want to be clever, but StepOver or out base is StepOver. Doesn't really matter. So StepOver sets this to true. I mean, like that. StepOut. Basically, I'm just going to use inheritance here. Now, by doing this, I still have a specific type for each, so it'll map to the target state one, and it'll automatically set the is StepOver. And then what we do is we say StepOver or out. I guess I don't need to say base here. Let's say StepOver or out as a name is fine. Now the question is, will this visit work polymorphically? I think it will. I think it will. So this should catch both cases, right? Like we'll never enter the StepOut anymore. And what we can do is when we're doing our check here, if it's less than or equal or less than, we could do the check but based on if it's a StepOver or not, right? So what do we do here? We say location source location changed. Pyro, still thinking about the last target state and target state you had. Don't you want to reassign last target state in the if not equals? You had it outside of the statement, which means you had that race condition or whatever it was called. If not equals. You mean, okay, you mean before I did this. Yeah, you had outside a statement, which means you had the race condition or whatever it's called. Don't you want to reassign last target state in the if? So the thing is that even if I do that, maybe, but the fact is that I have two variables, right? One that I'm setting from another thread, and then another one that is related and gets updated from that same one. And there's this window of time where one can get changed, you know, after the last one gets set, but before we notice it. So basically it's a race condition, and this is not really the best way to do it. Even what I have now is not amazing, but I've sort of removed the race by mapping it one-to-one with the current state. It's true that, say we're doing our switch and the target state is pausing, and when I hit here, the other state sets it to something else. For that one frame, we're not going to, or let's say one frame, at that moment, we're not going to go to the right place, but it's okay because the next time around we will, because I've removed the cache. Basically, that's the problem. The last state is a cache, and the cache is not synchronized. Now I've basically removed the cache. You know what I mean? So by removing the cache and having just the one variable that is the true target state, it's I'm able to catch when it changes and make sure I go to the right place. There's for sure still a race condition somewhere in here. This isn't really how I should be doing it. What I probably should do is have some kind of queue, like a thread safe queue of target states, or requests that are being made. And then I should basically process to queues. This way, like if the user like really quickly does a bunch of stuff, you know, like pause play and sets a breakpoint, and there's all these things at the same time. I have to have a thread safe queue that says these are the things that have been requested. Perhaps have a pass over the queue to, like, you know, null out entries, or make sure that I process them in order. That's sort of what I need to be doing here. This thing I have right now of like, it's kind of like a queue, except I'm only setting the last value on the queue. And I'm not really consuming it, right? I suppose what I should do is, as soon as I've consumed it, I should reset it. But that's the thing. I can't really do that now because it's this one atomic variable. I would really need a queue. So that we're pushing to the queue from one thread, and, you know, basic consumer producer. So the DAP thread is a producer of requests, and my main thread is consuming those requests. No, I hear you, but the problem is that I have two states, like I have a target and then I have a current, right? And with the last, I had a third one. And so now I had to synchronize between the three. Target gets set to something, then I need to make sure that my current gets set to what my target is, and that my last is being, you know, is used to make sure I don't do it more than once. And once I have that, the only really safe way to do it is to lock a mutex around the whole bit of checking if I need to change state, and if I did that, I would just have this mutex lock every single CPU cycle, like every single instruction, and I sort of want to avoid that. So maybe I won't be able to, but maybe with some kind of, you know, lockless, lock-free queue, I might be able to do it. So we'll see. But for now, this is, I think, good enough for what I gotta do, and I'll sort of solve the problem of, you know, users doing crazy stuff, which is totally possible, right? Like, you could be setting a breakpoint and hitting pause and doing something else at the same time in the debugger. There could be also a delay between the time the debugger sends me these requests and when I process them. So they may all come in one after another, and I need to make sure that everything is completely safe. So I definitely need to do this with the queue in my mind. Right now, I'm very much assuming that the user of the debugger is playing nicely, which I am, right? I'm not doing anything crazy. I'm just stepping slowly, setting breakpoints slowly. I'm behaving, you know, green path. But yeah, it's not really the right way to do it. So stack depth. What do I say here? Source location change. So stack depth, it's not changed, but I don't know how to call this. It's either less than or equal to. So I don't know, let's say stepped, because it means either we've stepped out or stepped over. I'm not sure, but let's do it this way. And then we say, if it's a step over, then we're checking this exact one here. Otherwise, we're doing this. How about, yeah, all right, whatever. So let's see. If it's a step over, it's less than or equal to. If it's a step out, then it's this here. If source location changed and stack depth stepped, right? Yeah. Would it have worked if you had an extra variable, maybe a bool, target state updated, that's set whenever the target state changed? Use that extra var for the if update, update 0, switch. The thing is, it's always the problem of, we have to always think that there's two threads here, right? So maybe, but it's probably pretty close to what I have right now, right? The truth is I didn't really like anyway what I was doing before, because I don't like the state being changed from the outside. That was a temporary measure at best. Ideally, it's what I'm doing here. You know, right now, each state checks for transitions. This allows me to do things like I could decide when to check for a transition. Maybe I need to do something before it happens. Maybe I need to do something on my way out. You know, like maybe before I return, I know I'm leaving. So this is basically my on exit code here. You know what I mean? So that is already a better deal. I may also want to do stuff like not allow certain transitions. Right now, I'm allowing all transitions to happen from any state to any state, but I could eventually, you know, say maybe while I'm pausing, I don't allow transitions to something else. You know what I mean? So this is definitely the direction I need to go, and ultimately, yeah, I will be changing the guts of this. Probably doing some kind of pull off the next thing from the queue in my check for transition and deciding what to do. Okay, so let's see. If this worked, we should hit this state for both step over and step into. So let's see if this builds. I'll be honest with you, I'm not a multi-threaded programming expert or anything like that. I have some experience with it, but you know, I haven't written a whole ton. So, you know, this is how I learn, right? Sometimes it comes as a surprise to people that I haven't done that much multi-threaded programming, but the truth is, if you've worked in games like I have for a very long time, you know, despite the fact that now and for a little while games have become much better at utilizing you know, more of the cores, for a very long time most games were practically single-threaded. You know what I mean? All right, so I just shift F11 and it didn't seem to do the right thing, which is interesting. Let me see. Let me put a breakpoint here. So F10 makes it in here, but not F11. Definitely makes it in here. Actually, I'll put my breakpoint in there. Now, what state are we in? Are we in paused? Oh, I can't even put a breakpoint here, can I? That's just annoying. Let me see. So index is 5. 0, 1, 2, 3, 4, 5. Yeah, so we're definitely in the paused state. Now we're going to go into StepOver out. Try F11 again. So I just did F11. We are presently in the paused state. Unfortunately, I can't seem to. Here we go. Check my stack. Yeah, I'm getting some unfortunate inlining there. But anyway, current state is paused. The target state is step into. Wait, what? Right, okay, so I keep hitting F10. That's why. Gotta stop doing that. So let's say I do Shift F11, but before I do that, no. Okay, so I've got the step out target state here. So now, step out. Okay, so current state is paused. We'd like to go to step out. So we set our state to step out. So is StepOver is false, entry is true. This looks right. So I think what happens now is that we just don't make it into this state. Index is 4. Step out is correct. But yet, oh, here we go. Oh, right. Yeah. This check for transition is what knocks me out. Of course. So as I was saying, this here was meant for being in one state. Let me just hack this. So all I did was add a second state that we optionally can check for. It's set to invalid by default, so it won't do anything in most cases. But in this case, I will be checking for 2 states. See right there, you can see the advantage of having a bit more control over the transitions we're going to make. Okay. Did I not attach? I did. Where are we at? Waiting for DAP. Okay, so something went wrong here. Let's try this again. F5. Oh, okay, here we are. Disable all these breakpoints here. All right, F10. Let's just get rid of these. All right, F10, all right, F11, Shift F11. All right, there we go. Select game. It's looking good, guys. Looking pretty good. There is something that I'm not handling, which is that while we're in the StepOver state, I had written a note about this, but while we're in the StepOver state, or StepOut, let's say, if we hit a breakpoint along the way, we should break, which is something I'm not handling at all. And it was something I had thought about last time, so definitely we have to do that. So let me just make a note about that here. Oops. Handle if a breakpoint is hit during StepOver or StepOut. So that's what I got to do, because I just realized now I have a breakpoint, but I'm in the process of doing a StepOut, and that is why, like, I'm not actually hitting this breakpoint that I set. So if I hit F6, I pause. Now if I hit F5, see this breakpoint that I set on the play sound, this happens if I hit the right wall. I should have hit that on during my StepOut. You know, if I hit F5, as soon as it hits the right wall, it's going to break. Boom, right? But now if I shift F11, I'm on my StepOut. Because I'm in an infinite loop, see there, it should have broken. I'm in this infinite loop. It's waiting and waiting and waiting. And there it should have broken. Because even though it's on its way to stepping out, if any breakpoint occurs during that time, it should break. And I am not handling that in this state here. So that's something else to do here. I'll put it here. To do, if we hit a regular breakpoint, we need to handle it as well. Okay, cool. So let me delete this. So that's pretty cool. Step out and step over is a step over or out here. Allows me to see, that's pretty neat with variant that I can do this, right? I can visit the state and I can put a base class ref here, and I'll get either one or the other here. So that's really cool that that works. Another great thing about using variant to handle state machines is this kind of thing. So I think this is a pretty good place to stop. I'm gonna just delete that here. It's a good place to stop. Next time, in a couple days, I'll continue from here. We'll fix the regular breakpoint thing, clean up a bit of code, and after that we'll move on to, I'm not sure, watch, variables, stuff like that. So, all right. So yeah, I'm pretty happy with this. Thanks guys for watching, and I'll see you next time.